Hello students, we are in the last exercise of real number today, that is exercise 1.4, and it deals with the decimal expansion of the rational number. Rational number we have learnt in our earlier classes, we have in our class standard 9 also we have learned the thing, and it is a number in the form of p by q where both p and q are integers and q not equal to 0 is called a rational number. This is the p by q form of a rational number, p by q form. So a rational number can either be written in p by q form or it can be written in decimal form as well. Simply, if we divide p by q, we will get the decimal form of the rational number. For example, I say 2 by 5. Yes, it is a rational number. What is its decimal form? Decimal expansion will simply be 2 by 5 is the p by q form and its decimal form is 0.4. So the decimal form of 2 by 5, a rational number which is in the p by q form, its decimal form is 0.4. Take another example, 7 by 3. P by q form is 7 by 3 and this 7 by 3 is rational number because 7 and 3 both are integers and 3 is not equal to 0. And what will be its decimal form? We will simply divide 7 by 3. 7 2s are 6, 1.0, 3 3s are 9, 1.3 3s are 9, 3 3s are 9. It will go on. So there is a difference between the two. In 2 by 5, when we are converting that p by q form in decimal form, in case of 2 by 5, we are finding that remainder becomes 0. But when we are converting the rational number 7 by 3 in the p by q form, we find that remainder never becomes 0, never comes to be 0. So this is 7 by 3, we will write it as 2.3 recurring over 3. That means digits after the decimal starts repeating. So this is also a rational number. So rather it is a surer check. If any number is given as 5.273 recurring over 73, and if it is asked whether it is a rational number or irrational number, you will say no, it is a rational number. Two types of rational number we are getting then in the decimal form. Decimal form of the rational number, the one is terminating decimal and the other one is non-terminating repeating, that is recurring decimals. All recurring decimal numbers are the rational numbers. So this is the thing. Now suppose a number is given to you and you have to check whether the given number has a terminating decimal or non-terminating decimal. What you will do? Simply we will divide p by q and we see that whether it goes completely, whether the remainder becomes 0 or the digits after the decimal recurs and the remainder never comes as 0. If the remainder becomes 0, we say that it is terminating decimal, and if the remainder is not 0, rather the digit repeats, we say it is non-terminating decimal. Both terminating decimal as well as non-terminating decimal are rational numbers. But in order to find out a given rational number, whether it is having a terminating decimal or non-terminating decimal, without actual division also we can say. For this, what you have to do, we have to take the help of the prime factorization of the denominator of the rational number. We will take the prime factors of the denominator of the rational number. Say, our rational number is P by Q. If Q is equal to 2 to the power m into 5 to the power n, if the denominator Q is in the form of 2 to the power m into 5 to the power n, where both m and n are non-negative integers, then P by Q has got a terminating decimal presentation. So this is the thing. So what we will do, we will simply find out the prime factors of Q. And if the prime factors of Q consists of only 2 or only 5 or 2 and 5 both, then it will have a terminating decimal presentation without actual division, you can say so. And if the denominator Q, if this Q is not in the form of 2 to the power m into 5 to the power n, what I mean to say, in the prime factors of Q, if any digit occurs other than 2 and 5, we will say that it will be non-terminating repeating. So without actual division, we are now in a point to say whether the given rational number has a terminating decimal presentation or non-terminating repeating decimal presentation. Let us start with exercise 1.4 now after giving this concept. In the first question, there are 10 questions. I will just pick up 3 of it. The very first, without actually performing the long division, state whether the following rational numbers will have terminating decimal expansion or non-terminating repeating decimal expansion. The first question of question number 1, 13 by 3125. So this is the question in the P by Q form. And we have to say whether it is having a terminating decimal presentation or non-terminating repeating decimal presentation. What to do? We will do the prime factors of this 5. See, here 3125 is equal to the denominator we are taking is 2 to the power 0 into 5 to the power 1, 2, 3, 4, 5. 5 5s are there and no 2s are there. Therefore 2 to the power 0. What is the meaning of 2 to the power 0? 2 to the power 0 means 1. So hardly it matters. 3125 is equal to 5 to the power 5 simply. But we are writing it in the form of P, which is in the form of 2 to the power m into 5 to the power n, where m equals to 0 and n equals to 5, both non-negative integers. Therefore, 13 by 3125 has a terminating decimal expansion. See, without actual division, we are commenting. If you do divide, you will also find the same thing. Here, without doing the division, we are commenting whether it will have a terminating or non-terminating repeating. I hope you have understood. Now take question number 3. 64 upon 455. Students, a very important thing I should tell you over here, before checking whether it has got a terminating or non-terminating repeating decimals, you see, first verify whether the given number is in its simplest form or not. You can, if it is not, convert it into simplest form and then take the prime factors of the denominator cube. Otherwise, your answer may be wrong. So here 64 and 455 both are co-prime to each other. That means it is already in the simplest form. We will take the prime factors of the denominator 455, 5, 9, 1, 7, 1, 3. So 455 can be written as 5 into 7 into 13, which is not in the form of 2 to the power m into 5 to the power m, where m and n are non-negative integers. Therefore, 64 by 455 has a non-terminating repeating decimal expansion. Hope you understood it. We have taken the prime factors of 455. We got the prime factors are 5, 7 and 13, which is definitely it is not in the form of 2 to the power m and 5 to the power m. Neither 2 is coming, nor 5 is coming. So we can say that 64 by 555 has a non-terminating repeating decimal expansion. The third question of question number 1, I will discuss one more question. Question number 10, that is 77 by 210. Right now I told you. After getting the question, you see whether it is in the simplest form or not. It is not in the simplest form, so we will convert it. 7, 11 upon 30. We cancel 7, 11 upon 30. Now we will take the prime factors of 30. 5, 6, 3, 2. So 30 again is 5 into 2 into 3, which is not equal to 2 to the power m into 5 to the power n due to existence of the third number 3. Where, don't forget to write this one, m and n both are non-negative integers. Therefore, 77 by 210 has a non-terminating repeating decimal expansion. So this is all about your question number 1.4. I hope whatever idea I have given, on the basis of that, all the questions of question number 1 of exercise 1.4 you can solve. Let us come to question number 2. Write down the decimal expansions of those rational numbers in question 1 above which have terminating decimal expansions. Those terminating decimal, those in question number 1, 10 questions are there, and those which have got the terminating decimal expansions, you have to write that exact decimal forms. What you have to do? You have to divide. You have to divide the numerator by the denominator, very simple process, and you will convert it into decimal form. Whatever decimal form you are getting, you will write down that answer. I have not to discuss it separately. So question number 2 is actually the outcome of the question number 1 itself. Only you have to give the decimal expansions of only the terminating decimal expansion. That is, you have to give the terminating this decimal expansion of this. And for that you have to do the division process. And I know that you are knowing how to divide. Question number 3 we are discussing, and that is the last question. The following real number have decimal expansions as given below. In each case, decide whether they are rational or not. If they are rational and of the form P by Q, what can you say about the prime factors of Q? So, that is question number 3. Our first question is 43.12345678 9. Such a big number. So many digits are there. Now you have to comment. The following real numbers have decimal expansions as given below. In each case, decide whether they are rational or not. The first one is this one. Let me write the second one also so that we can compare the result. 1.20, 1200, 12000, 12000, dot, 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 dot. And the third one is, question number 3 is 43.12345678 and 9. Recurring over this. If they are rational, okay. First we have to identify whether they are rational or not. See this question very carefully, this number very carefully. Is there any dot 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 sign? No. Is there any recurring sign? No. It means it has got a terminating decimal and hence it is rational. It is rational number. And if it has terminating decimal, and the prime factors of the denominator will be 2 and 5. Without doing anything, just see whether it is terminating. If it is terminating, it is a rational number, and the prime factors of the denominator will be 2 and 5. Second one, see the number 0.12, 012, 0012, 00012, 000. Is there any dot 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 sign? Yes, there is. Can you put any recurring marks over any digit after the decimal places? No, we cannot. Because the digits that are appearing after the decimal place, they are not following any sequence. So, what we can say? That it is non-terminating and non-repeating decimal. And if it is non-terminating, non-repeating decimal, it is an irrational number. Remember, when I was explaining a rational number, I told you the decimal presentation of a rational number are always non-terminating and non-repeating. The last one, we are finding recurring sign. If recurring sign is there, definitely it is rational number. And what type? Non-terminating, repeating. It is a rational number of non-repeating non-terminating repeating nature. So the prime factors of the denominator. So a prime factor of the denominator. So the prime factor of the denominator will be other than 2 and 5. There can be 2 and 5. There may not be 2 and 5. But apart from 2 and 5, including or not including 2 and 5, we will get another prime factors, 3, 7, anything else. So this is a rational number of non-terminating repeating nature. So if prime factor of the denominator must be other than 2 and 5. So this is all about your chapter 1.4. Thus, student, we have completed the chapter of real number. In our next class, I hope you will go through the exercise and try to do each and every sum that I have explained. And I think, and I hope, I'm quite sure that you can do well all the sums given in your exercise. And in our next class, we will meet with the second chapter, polynomial. Till then, goodbye.